Thus far, we have discussed how to use linear regression to carry out estimation, and how to determine if the estimate obtained is reliable, by considering both the data range, and the strength of the linear relationship for the data. In this section, we will discuss how we can use transformations to convert nonlinear models into linear models, so that we can also carry out estimation when a set of bivariate data demonstrates a strong relationship that is nonlinear. Suppose we notice from the scatter diagram that a rectangular hyperbola appears to be a good fit for the data. In other words, y equals to a divided by x plus b is a curve that may fit the data well. What we can do in this case is to introduce another variable, say w, and let w be equals to 1 divided by x. By doing so, we can then perform linear regression between w and y, and use this model to estimate values of y given values of x, and vice versa. This process of carrying out a transformation to achieve linearity is known as linearization of data. Some other examples on how linearization of data can be carried out for various nonlinear models are as shown on the screen. We will now look at an example which illustrates how we can use the product moment correlation coefficient to determine the goodness of fit of a nonlinear model, as well as how we can carry out linearization of data if a nonlinear model is known to be appropriate for a set of bivariate data. Refer to example 5.1 in your lecture notes. An experiment is conducted to determine the relationship between the variables x and y. The table, as shown on the screen, gives the experimental values. Find, correct to 4 decimal places, the product moment correlation coefficient between a, x and y, b, 1 over x, and y, c, ln x, and y. Use your answers to parts A, b, and c, to explain which of y equals a plus bx, y equals a plus b divided by x, and y equals a plus b times ln x, is the best model for this set of data.